Let's talk about mathematical models. A mathematical model is anytime you have a system and you're describing it with an equation, right? That's what a mathematical model is. We're going to refer to mathematical models specifically when we're using the equation of a trend line to generate the relationship between two variables. So here are the steps. I'm going to go through them with some examples. So you may want to pause, write these down, and then we'll go through them one by one with 5 examples. So here's our first example. This is the trend line, from the graph on Excel. Here is the equation of the line. So what does how do we generate the mathematical model? So you're looking specifically at this here, this y equals 1.5082x plus 0.0596. So this is y equals mx plus b. So first step is to just simply rewrite that equation. Write it. The second step is to type in or write in the variables that correspond. So y is time and x is mass. So you rewrite the equation with those words instead of the x and the y. It's very simple. Notice I left some blanks here. These blanks are spaces for units, and I just usually do this in 2 separate steps. So you want to write out the equation with the words in first, then all coefficients need units on it. So time doesn't need a unit, mass doesn't need a unit, but the coefficients do. So how do we do that? Well, we always put the unit for the y-axis for time first. So you'd put seconds here and seconds there. The second step is to put the units that if there's a variable next to the coefficient. So the first term here has mass next to it. The units of mass are kilograms, so we're going to divide by kilograms. The second term here does not have any mass next to it, so it does not need to be divided by anything. So in the end, you look at this. Time equals 1.5082 seconds divided by kilograms times the mass plus 0.0596 and just seconds. Let's go through this again. Here's another linear equation, right? Here's the equation. I'm going to just write that. So I've written that out. Now I'm going to substitute in the terms. The distance is the y, the time is the x. So let's write that. Distance is the y, time goes in where the x was. There's a blank space, right, available so we could put in the units. So to do the units, we always put in the units on the y. So the units on the y-axis are mass. So we fill in mass here, mass there. Then we're going to divide by the x units if there's an x next to that term. So this has time is seconds, so you divide by seconds. This doesn't have anything next to it, don't need to divide by it. And that's what your equation ends up looking like. Example 3. This equation is also linear, y equals 99.082x. So we're going to first write that out. The y-axis term is voltage and the x-axis term is current. So we rewrite it with those terms in place, leaving a blank space for the units. The units are going to be your y-axis units divided by your x-axis units. Right, here's current right here, so you're dividing by the current units. So we get V over A. Fourth example. This has speed versus position. You have a linear equation here for negative 48.7x plus 120. Rewrite that equation. Substitute in the variables. You've got speed on the y. Position is x. So you just put those in, leaving blank spaces for units. The y-axis units, meters per second. Fill that in, meters per second in both blanks. Position is multiplied by this term, so you have to divide by those units. So divide by mass here. 120 is by itself. You don't have to worry about any other units. So meters per second divided by meters. I know that looks weird, right? Just leave it for now. We'll worry about the rest later. Here's example 5. We've got y equals 0.2587 x to the 1.9, well, 1.139. First, rewrite the equation. right? Just write it straightforward. This is a little more complicated because it's a different type of curve. Then you're going to substitute in the y-axis term, the x-axis term. But notice I also did one other thing here. I rounded this exponent to the closest common number that we use. So we either use 0.5, 1, or 2. That could be either positive or negative. So we don't leave those fractions, those decimals in. We round it to the nearest common value. Now we got to put in the units. Y-axis units are seconds, x-axis units are meters. So we do seconds over meters, but now because the length is squared, we have to square the meters. So you end up with seconds over meters squared. And that's your mathematical model.